So let's start. While I get the eraser, if I could. So I send an iClicker question. They are on the right screen. Okay, so first, maybe let's go over administrative of the class. I haven't sent you the updated grades, but I will. There is a reason, not because I forget, not because I'm lazy. I want you guys to focus on the lecture, and then I'll send your grade right after. That includes your iClicker scores, your adjusted exam. So, and then if your last name starts with A, you will get it first. That's just how Canvas works. So this is the code that I wrote. Basically, in terms of your exam, it says here, can you read? Okay. So I don't know who this person is, but these are different students right here. Let's select randomly. So this person received 5.5 out of 14 questions. So what I did is type, divide the score by 14, multiply by 100. So that's in percentage, and then plus 15. Because 10 is too low, 20 is too much, and I don't overthink it. Just meet halfway, 15, and this person received 54.3. So that's one. Don't expect another adjustment throughout like this semester unless something happened. Right? Because I hope you guys will perform better. You can bomb an exam once, but hopefully not twice. Yeah. Oh, how? Yeah. So is that you? Okay. So the question is a good question. How to study for the exam? I guess my lecture or my class, I'm running this class slightly differently than Frank or Sen. I put about 50% of the questions on conceptual understanding. So if you are not sure about your understanding of, let's say, potential, or in this case, for today's lecture is Kirchhoff's law, then you should ask me or ask your TA. What I'm gonna do, since we are here to help you, is we plan to add more conceptual questions to your study guide. And then hopefully that will better prepare you. But don't expect, so physics is not pattern recognition or memorization class. It's not like, oh, you see kilogram, then it is M. You see centimeter, then it's R. But it's centimeter, I have to divide by 100. That's not what I want you to get a lot more than that from this class. And this is not like anatomy class. Knee, bone is what patella, I think. You don't need to memorize. We will give you the cheat sheet. But we expect you to know, for example, the iClicker question is how many equations that you need to solve and number of unknowns. You should know that because it's useful. Even some engineering students, they don't know that. Any other questions before we start? Okay. So let's start with the simplest equation, which is one unknown. Let's say x. I don't know, x equal to 15. Then you only need one equation, right? Because after writing one equation, then you know. So this is unknown. Number of unknown 1. How about for 2? How many that we need? Let's say, I don't know, you say x plus y equal to 3. Can you figure out what X and what Y is? No, right? X can be 0, Y can be 3, Y can be 0, X can be 3. So you need more than that. You can probably, this one is also another equation. Then you know if X plus Y is equal to 3, X equal to Y, then X is equal to Y is equal to 1.5. But without the second equation, you will not be able to figure out what X and Y is. Okay. So by induction, this is just example, by the way. Then for n equation, you need n. So that's, you will use that for circuit analysis today. So if you want to change your answer, you can, but it's small points, and I will grade later today. And this iClicker will not be included in the email that I send you today, because I still need time to grade it. So the answer is N. So one example from your perusal, someone may give you this this circuit. Don't worry about the details. We will learn about Kirchhoff's law 1 and 2. The question is how many unknowns are in the circuit above. If you're not sure, just put answer, and we will not spend too much time because we haven't discussed Kirchhoff's law. Okay. And I'm going to change it to numeric. So let's spend 20 to 30 seconds on this. Okay, 10 more seconds. 3, 2, 1. So what is the answer? So most of you got it right. If you missed it, so what are the unknowns? So if somebody gives you 12 volts, you know exactly the potential. 1 ohm, 1 amps, 2 amps, 3 ohms, you know the potential or the resistance or the currents. The unknowns are actually labeled in red. The EMF or the voltage drop or the voltage increase, R and I. So there are 3 of them. Okay? If it takes time for you to understand it, don't worry. We will do a lot of examples in this lecture and in the lecture on Monday. Okay, so the answer is 3. All right. So in today's lecture and in Monday's lecture, we will talk about electrical circuits that cannot be reduced to simple either series or parallel. So remember, like one of the examples, I think on Wednesday, circuit that looks like this. And then this circuit, when in this class, when we draw this, that means there is a voltage, there is a battery somewhere. This circuit can be reduced to a parallel circuit of 3 resistors. Okay. And this can be further reduced to just 1 resistor. So this is basically if somebody, so people ask me, why do we have to learn this? Well, that's part of pedagogy. But imagine if somebody gives you something, cell membranes, let's say, and put this in a black box, and you make measurements, then the question is, what is the circuit here? And then you can collapse all of the resistors into 1 resistor. But the circuits that we will discuss from now on they cannot be reduced to a simple, to a single resistor. And again, when I draw a circuit like this, when I say circuit, that means a closed circuit. There is a battery somewhere in the circuit. So you can try, but all of the circuits you cannot reduce into one resistor. So in this one on the left, there are two batteries and three resistors. And the one on the right, there is a complex, we call it junction. And they are, and you can, again, cannot reduce them into one resistor, okay? So next, there are some definition. One is the one that we will probably never use in this class, which is a branch. A branch is part of circuit that connects to junctions. So this is a branch. But more important definition, let me just show you. More important definition is junction. A junction here is defined as a point where at least three circuit paths meet. Okay. So here, so in this example, A is a junction because there are three circuit paths, and B also a junction. But D is not a junction because there is current here, which is equal to the current exit this point. Okay. We will have an iClicker question soon. Do you have question at the back? We will not continue until you finish. Yeah. Do you have question? Okay, good. Thank you. So, so let's. Do you get it? The difference between junction and not a junction. So now we have the simplest circuit in the world, which is a battery and a resistor. The question is, what is the number of junctions? And I'm sending this to iClicker. So junction requires more than two, basically branches. 10 more seconds. 5, 3, 2, 1. Good. So 90% of you answer correctly. The answer is 0. So this point, some of you may think that this point is a junction. It is not. This point is not a junction. This point is not a junction. So the answer is 0. Now let's do this. I don't know whether this thing will be successful or not, but I'm going to ask you to point the junctions. Okay. So there are, so firstly, I just realized that there are two junctions and you can only point one. So there are two junctions and I want you to locate the junctions. And if it doesn't work, don't worry about it. It's an experiment. So I'm sending this to iClicker and let's watch the output together. Okay, good. So all right. So you guys basically get it. Very easy. 10 more seconds. Three, two, one. Let's see if I can grade this. I think this is how to grade it now. Yeah. So there are two. Sorry. I can only. So this one is not correct. So when I grade it, I should do like this. But some of you didn't answer correctly. This I don't know, 3 people or so. far, so good. This is similar, not similar circuit. The question is how many junctions? Now there are some unknowns and some numbers. So this is really easy, should be easy for you. How many junctions? Does the circuit have? All right, three more seconds, 2, 1. Okay, good. So the answer, I took a pick. The answer is 2. So like last time, the position of the junctions are either here, not either, are here and so like node A and node B. And this corners here, it's not a junction because there are only 2 paths. Any question? B, so the answer is B, which is 2. So next, we will talk about Kirchhoff's first law. So this is the consequence of the conservation of charge or the conservation of current. Current is basically charge per unit time. So basically, we discussed this concept last time. If we have a path or a branch and we have current, like if for a component, I don't know, I left and the current on the right of the component, then in a path or in a branch, the current has to be equal. You cannot suddenly destroy charges or you cannot suddenly create charges. Okay. So the consequence is if you have multiple resistors, then I don't know, I very right, let's say, is also same. And if you have a branch, I don't know, like this, the arrows can point anywhere, can be 5. You know. Then the sum of the currents is equal to 0. Can you see this? The sum of the current is 0. So let's label the currents I1, I2, I3, I4, and I5. And right now you may think that I, or the I, which is the symbol of electrical currents, they are positive, but some of them can be negative. So if a current, so this one is for all junctions. So if the current points into a junction, then it's positive. If the current points away from the junction, it's negative. That's the convention that we use in the class. But you can come up with your own convention as long as you are consistent. Okay. So in this case, for this example, then I1 plus I2 plus I3. All of this 3 goes, sorry, I3 should be minus. And then plus, sorry, I4, and then minus I5 is equal to 0. Simple. So one analogy is current is a flow of matter, in this case charge, but if it helps, your book use water flow as an analog of electrical currents. So if you connect, let's say, a few tubings, you cannot suddenly destroy water in the middle of in a junction. So in the plumber or like the plumbing analog is this one is a junction. You cannot suddenly have water in without anything flow, or water out without an outflow. So the sum of the current is equal to 0. And this is a simpler example than the example that I just came up for the class. Okay. So I have this iClicker question. So we have a junction. There is one unknown. Okay. There is one unknown. So how many equations that you need to solve that one unknown? One, right? And I want you to be careful with the sign. Because when the current goes into a junction in this class, the sign of the current is plus. If it points away from a junction, then the sign of that particular current is negative. So it's a multiple choice. I give you a minute, or if you need more time, we can spend more time on this. But should be fairly easy for you, just a little bit tricky. Okay? And you can discuss this iClicker question with your neighbor. What's your answer? Why? Okay. Sometimes you have to, in physics, sometimes it's easier to write the equation. So the equation is all right. So basically, almost all of you have answered. 10 more seconds. Good. I don't know whether this is good or not. Sorry, I misspoke. When I say good, I ignore that. Suddenly you guys are quiet. All right, so all of these are low risk assignment. Don't worry so much. As long as you learn from the iClicker question, that's all I care. Meaning like that what makes me happy. Okay, so let's stop. In physics, in math, and sometimes in life, or yeah, it's for me. I always write down the equation. I'm actually like you. I'm not a pre-maths, but I like solving equations. Based on your exam, most of you are really good with numbers, but the conceptual is something that we still need to work on. So since this is the one that will be on YouTube this afternoon, so let's draw the circuit. Okay. So this is the mystery current. And 1 amp here, 1 amp goes into junction, 1 amp goes to, 1 amp. Okay. So the equation is sigma. If you forget, sigma means sum. Sigma of I, whether in or out, is equal to 0. Okay. So this one is equal to, first, let's start with top and then clockwise. This one should be plus or minus? Plus. So plus 1 amp. Oh, sorry. Good. And then the second one, this one should be plus or minus? Plus, right? How about the third one? The third one is plus. How about the fourth one? Plus. So you have one equation, you know all of this except the mystery current, then you can find the unknown, which is equal to Negative 3 amps. Give me a second. My Apple Pencil. Middle card. Oh, okay. This is why we need LA. Okay, good. So that means the answer is D. So basically 50% of you got it right. B is almost there, but not quite, because the sign has to be negative. And this is one of the rare moments in this class that the sign is very important. The amps, yeah. Yeah, so what does, okay, good question, excellent. So what does negative current means? That means it points the opposite direction of the arrow. So you put more charges, something needs to go out. But this is just a sign that you guess. So in differential equation, in physics, in math, sometimes you guess. Like when you go to fries, you guess the sign of X, right? Like I buy plus 1 dozen of X. Oh, yeah. I could, okay. So on the exam, this is not my favorite thing to do. I don't like to trick my students. I can, some of you may disagree, but one can come up with this question. Then the answer is plus. If I flip the arrow, then the answer would be B, but not this one. You can use your intuition, and then if you get negative current, that means your guess is wrong. It's sometimes you just guess. You know that tomorrow will be Saturday, but you can guess tomorrow is Friday, then you just need to add one. Yeah. Oh, yeah, Gabe. Positive out of the junction. Yeah. Wait, sorry. What do you mean? Sorry. Can somebody, can you repeat your question? Positive out of the junction. What do you mean? Is okay, I thought that, okay. In this problem, positive out of the junction, but in terms of the sign, positive is into the junction. I'm not sure which one that you asked me. Are you asking our convention or this problem? The whole thing. Good. I like that. So in all problems, if the current goes into the junction, then it's positive. If the arrows point towards a junction, then it's positive. Did I say negative? It's positive. If it points away, then it's negative. Yeah, so the problem states like this, but our answer is 3 amps. That means it points into the junction, but the amount is -3. This is the same like if I say you owe me -$100. That means you need to, sorry, or it's easier to think the positive, the magnitude in positive language or positive tone. I give you -$100. That means you need to give me $100. But if I give you plus $100, then I give you the money. But if I give you minus, then you give me money. We can discuss after the class. Okay, but we have to move after this. Yeah. Yeah. Oh, because in terms of physics, you put charges into a junction, something needs to exit the junction. Okay, good. This is actually a good question. So this arrow is given, and soon you will guess the directions of the arrows. You have to, otherwise you cannot solve problems. Sometimes you have to guess, and then if you get negative answer, that means it points the other direction. Yeah, so this is a wrong direction. It's fine. It's like it's mathematically accurate for me to say that I give you minus $100. It's mathematically accurate. No one will say that, but it is actually meaningful. I think we have to move on to this. So the thing is, okay, let's just do a simple example. Let's say the problem looks like this. So this, you want another example, right? Without spending too much time. Then this one move away from the junction. Therefore, the sign of the mystery current is negative. And if you solve the equation, you get positive 3 amps. And similarly, one can do like this, let's say. Then this one will be negative. Then this will be 2 amps. Okay, and you can have a lot of permutation. Okay? As long as you are consistent, then we're good. So now it's 10:42. So let's skip this question, but this is, I think this one appears in last year's exam or 2 years ago. Basically, Kirchhoff's first law, so this one is called Kirchhoff's first law. Some textbooks call this law junction rule. It is a statement of the law of conservation charge or conservation of currents. So the answer is B. B. I think we have practiced quite a bit for Kirchhoff's first law. Now is Kirchhoff's second law, or junction or loop rules. Okay, loops. So what is loop? So imagine if you go to South Mountain and you stand here. A loop is basically if you go, take a path, and you return to the same point. So this is one loop. This is another loop. Okay. This is also another loop. So you take a point, and if you return to the same point, then that thing is a loop. So how many loops in this mountain? 3 loops. 1, 2, and then 3. Okay. So 3 loops. If we translate this mechanical or gravitational analog to electrical currents, that means the voltage in a loop goes back to 0 because the elevation is the same, and elevation or height is the gravitational analog of electrical potential. Okay. So the sum of all voltage is equal to 0. So here, and this is a consequence of conservation of energy. You hike, you return to the same point, then the gravitational potential energy change is equal to 0. So, okay, let's do this exercise. So we have the same circuit. We did the circuit before, but instead of asking you to point the junctions, I'm asking you the number of loops. Okay. So it will be a number. Oh, it will be a multiple choice. And you can discuss this with your friend. Fifteen more seconds. All right, so what is the answer? The answer is? The answer is 3. So this is similar to the analog, the South Mountain scenario that I mentioned earlier. There are 3 loops. You can pick any points in the circuit. For fun, let's use this junction, which is easy. So you go, this one is one loop. This one is another loop. And the other one is this loop. Okay. So in the notes, I draw it like this. Any question? How about the direction of the loop? Remember, did you pay attention that I draw it clockwise? When you hike, do you always go clockwise or you just follow other people? Follow your wife. You can do. It's a free country. You can either do it clockwise or counterclockwise. Right? It's the same thing. You guess, and then if the current or the voltage is negative, that means your guess is wrong. As long as you know what negative means, or negative amps or negative voltage mean, then you will be fine. Okay. Next, this is something that is a bit tedious. When I was your age, when I was sitting as an undergrad, I didn't have cheat sheet, but this slide will be provided to you for exam 2 and the final exam. Okay. So the question is, what is the change of the voltage? Remember that Kirchhoff's second law is the sum of all voltage is equal to in a given loop. Remember, in a loop is always equal to 0. Okay? But that means some of the voltages can be voltage increase or a voltage drop. Okay? And you have to pay attention here. Otherwise, your answer may not be right. Okay. So first, typically my loop is clockwise, but you can do the opposite. But for this example, the direction of the loop is all clockwise. And then if the loop first hit the negative side or negative electrode of a battery and positive, then the potential change is plus. Okay. But somebody can flip the battery. Oh. Sorry. Somebody can keep the battery the same and guess the direction of the loop, the opposite direction. Okay. The one in the bottom, the loop is counterclockwise and hits the positive electrode and the negative electrode. If it hits positive first, that means you go from high elevation to low elevation, then the change of the voltage is negative. So if you follow all of this convention in terms of science, you'll be fine. Okay. So this is for battery. The right panel is for a resistor and a current. So first you need to guess the direction of the loop and the direction of the current. If the direction of the current is the same as the direction of the loop, then there is potential drop, so negative. Let me erase that so it will be cleaner. The slide will be cleaner. How to do that? Undo. Okay, negative here. If the direction of the current points the opposite direction than the direction of the loop, then you get a potential increase. And what is the potential increase or decrease? This is the Ohm's law, like R times I is equal to V, or V is equal to I times R. So either minus or plus. And again, you don't have to memorize this, but actually if you understand this convention, meaning what I'm trying to say is that you can actually understand this convention and you don't have to memorize. But this slide will be given on the exam. Okay. So how to solve well, first let's use a simple example. And let's start with the one on the right. The simplest circuit is a battery and a resistor. And what you need to do is you come up with the direction of the loop, the number of the loop, the direction of the loop, and you guess the direction of the current. It can be to the right or to the left, up or down. It has to be consistent, meaning it starts to the right, down, left, up, and right. Okay. Then using Kirchhoff's loop rule or second law, first the loop hits the negative electrode of the battery and then positive. That means the voltage change is plus. Okay. So plus. And then when it hits the resistor, the direction of the loop is the same as the direction of the current, so minus. And all of this has to be equal to 0. Okay. So some of you raise a valid concern about guessing. Guessing in my class is good. Let's say you're a big fan of counterclockwise. You do this, right? And the question is, will you still get the right answer? Okay. Will you still get the same equation? Okay. So if your loop is counterclockwise, the loop, when it hits the battery, it hits the positive electrode first, then negative. Positive, then negative, the sign is negative. So negative volts or EMF. And then when it hits the resistor, the loop points to the right, but the currents point to the left. So if the direction of the loop and the currents are the opposite of each other, the voltage change is plus. So if you compare these two equations, the one on the left and the one on the right, they are identical. If you multiply one of them by -1, then you get the same equation. So your guess in the end doesn't really matter. You may get negative current instead of positive currents, but you just need to be confident and do it. And like anything else, you will get better with practice. Any question? So one of the things that, so I don't expect most of you to be physics majors after this class. I had one that switched to physics, and he ended up with Goldwater scholarship. He's at MIT right now, mechanical engineering. But one thing that I want you to keep or to keep for the rest of your life for the rest of your life is, like, we need n unknowns to solve n we need n equations to solve n unknowns. You know what happens if we have more than n equations? What happens if we have more than n equations and we only have n unknowns? Yeah, you with a navy sweatshirt. Yes, you. No, not you, the other one. What's your name? Sarah? Sarah is that one. Yeah. Oh, Sarah. Sorry, I'm old. Yeah, you, the one with navy. Oh, what happens if you have n plus, I don't know. What happens if you have extra equations? Let's say you have n plus 1 equations and you only have n unknowns. Okay. So any guess? Yeah, Z. That's actually a bold guess. It turns out that it doesn't lead to different answers. So what happened all the time, and it has been like that for many, many centuries, is that what you have, let's say one equation is, this is just a random example, right? Something like that. Let's say if you use different loop, what end up happen, you may get like this. You may get either a combination or the same equation as you have derived before, or just multiplication. You multiply the same equation by something. So you don't need more than n equations to solve n. That things has been correct for many centuries, and I expect to be correct in the next many centuries. Okay, let's, so this could be the last iClicker question. Whew. Okay, okay, this is a junction rule. Unfortunately, this is the wrong iClicker question. Let's skip this for the next class, and you know what? Let me do an example in front of you on Monday, and then we can do a lot of iClicker questions. Is that good? And expect an email from me that contains your grade before 5 p.m. I have meetings right after this class. Have a nice weekend, and I'll see you on Monday. Oh, email. I'll email you. Oh, you're just gonna email us? Yeah, yeah. Okay. Hey, what's up? I just wanted to clarify the first house charge rule. Yeah. When you're changing the charge, like yeah, all you're changing is like this sign, not the sign of the actual number itself, right? You don't know. Yeah. So like, so this would be negative by mystery, but since it's pointing, I mean. Now it's negative. Yeah. Because at the end of the day, we always want to think about it has to equal 0. Yeah. So probably just thinking it in terms of this instead of trying to figure all this out. Yeah, but on the exam we will ask you. Yeah, but I'm saying like in terms of conceptual, this one is enough. Yeah. It's like at the end of the day, if I have all of them except one, I just not think about like what direction it is as long as I know that it has to equal 0. That's actually better if you can solve it using physical intuition. Thank you. Yeah. So. Yeah. Your grade increase? How? No, it's impossible. Can you send me your? How did you? What led you to? Yeah, this is why I keep my own grade book because even the iClicker doesn't communicate properly with Canvas.